Hi friends, I am Abhishek and you are watching the video of 10th Standard Mathematics. Today we are going to solve the examples which are given in the textbook. Here on the page number 5, example 1 is given use of Euclid algorithm. Use Euclid's algorithm to find the HCF of 4052 and 12576 or 4052 and 12576 by the method of Euclid's division algorithm or Euclid's algorithm. By solving with the long division method or the simple division method, we are getting 405 into 3, that is 12,156. 12,576 minus 12,156, so we are getting remainder as 420 and q, that is quotient, as 3. So putting all these values in the form of a is equal to bq plus r, we are getting 12,576 is equal to 4052 into 3 plus 420. Now taking A as 4052 and B as 420, we are getting the another division, that is 420 into 9, that is 3780. 4052 minus 3780, so we are getting remainder as the 272. Putting it in the equation of A is equal to BQ plus R, we are getting 4052 is equal to 420 into 9 plus 272. Here A is 420 and B is 272. Again doing the same division process, we are getting 272 ones are 272, 420 minus 272, that is 148. So here remainder is 148, q is 1. So putting it in the equation A is equal to bq plus r, we are getting 420 is equal to 272 into 1 plus 148. Now going further, we are doing the same division process. This division process is not done in your book, but I have done it to simplify the problem or to make you understand it in simple terms. 148 ones are 148, 272 minus 148, that is 124. Putting it in the equation A is equal to bq plus r, that is 272 is equal to 148 into 1 plus 124. Here A, now considering A as 148 and B as 124, again doing the simple division process, we are getting A as 124 and B as 24. Until we get the remainder as 0, we have to continue the process. Now again doing the simple division, we are getting 24 5s are 120, remainder is 4. Again doing the division process, here A is 24 and B is 4, 4 6 are 24. Now we are getting remainder as 0. Writing all these equation in the one line, we are getting 12,576 is equal to 4052 into 3 plus 420. 4 here, now considering A as 4052 and B as 420, 4052 is equal to 420 into 9 plus 272. Now A is 420 and B is 272. 272 into 1 is equal to 148. A is 272 and B is 148. 148 into 1 plus 124 is equal to 272. Now again A is 148 and B is 124. 148 is equal to 124 into 1 plus 24. Now A is equal to 124 and B is 24. 24 5s are 120 plus 4, 124. Now A is 24 and B is 4. So here we are getting remainder as 0. We will get the HCF of two numbers as the 4 because answer is always above the 0. Here we are getting 0. Answer will always be above the 0. Thus 4 is the HCF of 4052 and 12,576. Now we are moving to example number 2. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1, where q is some integer. Suppose we take b is equal to 2, then r is equal to 0, 1, because 0 is less than or equal to r is less than b, or 0 is less than r equal to 0 is less than or equal to r less than b, or 2. Here we have taken b as 2, that's why we will have remainder as 0 and 1. Therefore a is equal to 2q plus 0 and a is equal to 2q plus 1. We will not go forward because we have only 0 and 1 as the remainder. 2 is not taken as the remainder because here the condition is given, that is 0 is less than or equal to r is less than b, or 2. Therefore we will get the two things, a is equal to 2q or a is equal to 2q plus 1. So for here 2q is divisible by 2, but 2q plus 1 is not divisible by 2. Therefore every positive odd integer is of the form 2q. 2q can be divided by 2, so you will not get any remainder. But 2q plus 1 cannot be divided by 2. Thus, every positive odd integer is of the form 2q plus 1. Third question is in the same pattern of the question number 2 we have discussed earlier. Here you have to prove 4q plus 1 and 4q plus 3. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. Here we take b is equal to 4, then r is equal to 0 plus 0 comma 1 comma 2 and 3, because we know the condition that 0 is less than or equal to r is less than b, or 0 is less than or equal to r is less than 4. So we will get 4 equation: a is equal to 4q plus 0, a is equal to 4q plus 1, a is equal to 4q plus 2, a is equal to 4q plus 3. Here a is equal to 4q and a is equal to 4q plus 2 can be divided by 2, but 4q plus 1 and 4q plus 3 cannot be divided by 2. Thus, positive odd integer is of the form 4q plus 1 and 4q plus 3. Moving to the last question. Question is given: a sweet seller has 420 kaju burfis and 130 badam burfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number that can be placed in each of the stack for this purpose? You have to find the HCF. Though they have talked about the sweets, but our main goal is to find the HCF, because this is the question from Euclid division lemma or chapter number 1. So 420 and 132 numbers are given here. 420 is greater than 130, therefore 420 is taken as A and 130 is taken as B. 420 is equal to 130 into 3, that is 130 into 3, that is 390. 390 plus 30, that is 420. Second is 130. Here now we have got as the new A 130 and new B as 30. 30 for the 120, 120 plus 10, 30. Now A is 30, B is 10, 10 3 is 30. So we are not getting any remainder, therefore answer will be above the 0, that is 10. Thus HCF of 420 and 130 is 10. Thus we can stack burfi in 10 numbers, or sweet seller can make a stack of 10 burfis. Thank you friend and have a nice day.